You glance down at your hand and lift 4 fingers, and you know it is 4. You do not count them, and you do not run 1, 2, 3, 4 through your head. The number is simply there, instant and certain, before you have a chance to think. Right now you are doing something so easy it feels like breathing. For almost the entire time your species has existed, roughly 300,000 years, that instant 4 sat very close to the ceiling of what a person could hold in the mind as an exact amount. Past 3 or 4, the certainty blurs. Look at a heap of stones and you feel the difference between a few and a lot, yet the exact number slides away from you. Here's the part that should stop you. There are people alive today whose language carries no word for 7 or for 20. And for your ancestors, a wrong number was never a mark on a test. A miscounted store of dried meat could mean a winter that ran out weeks too early. So could ancient humans count? The answer hides inside a notched bone, inside your own 10 fingers, and inside the reason writing was invented at all. Stay with this because the story arrives in layers, and each layer is stranger than the one before it. Start with what you were handed at birth. You came into the world already able to judge amounts. A newborn only days old will look longer at a card when the number of dots on it suddenly changes. Show a baby 2 dots, then 2 again, then 3, and the baby stares harder at the 3 because something is different. The French neuroscientist Stanislas Dehaene spent his career on this, and he gave it a plain name, the number sense. It is a rough feel for quantity that sits under everything else, and you never had to learn it. You share this feel with animals. Crows can tell a smaller group from a bigger one. Lions listening in the dark will judge how many rivals are roaring nearby before they decide whether to fight or slip away. A hunting party of your ancestors looked across a valley at another band and made the same judgment in a heartbeat. More of them or fewer of them, without a single word for the total. Now here's the catch. This built-in sense is approximate. It is sharp at the bottom and fuzzy at the top. You can glance at 3 berries and know there are 3. You can glance at 4 and still be sure. Somewhere around 5, the certainty cracks, and you begin to estimate. Psychologists call the fast, exact part subitizing, and it stops almost exactly where your ancestors' number words tended to stop too. You reach 1, then 2, then 3 with real confidence, and after that, most old counting systems fall back on a single word that just means many. If that sounds too simple to be real, look at the living proof. Deep in the Amazon live the Piraha, and in the early 2000s, the linguist Daniel Everett reported something that started an argument he is still having. Their language has no fixed words for exact numbers. They use terms that mean roughly a small amount, a larger amount, and many, and the same word can shift with the situation. Everett watched adults who could hunt, fish, and survive in one of the hardest places on earth, yet who did not line up 5 sticks against 5 sticks and see them as the same count. They are not slow. They are not lacking anything in the head. They simply grew up in a world that never once needed the exact number 7, so their culture never built the tool. And that is the quiet truth under this whole video. Counting past a handful is a piece of technology. It gets invented, and it gets handed down, like a spear point or a fish hook. A brain does not grow numbers the way it grows hunger. The same picture turns up with the Munduruku, another Amazonian people studied by the researcher Piraha. They have words for numbers up to about 5, and above that they estimate. Ask them to point at which of 2 large groups of dots is bigger, and they are excellent, as good as any graduate student. Ask them for an exact 8, and the exact part has nowhere to live. Their minds run on the same approximate sense you were born with, without the extra machinery bolted on top. You can even watch that machinery get installed today. A young child can sing 1, 2, 3, 4, 5, long before any of it means a quantity. For months, the words are only sounds in a fixed order, a little tune with no meaning underneath. Then one day the child notices that the last word she says while pointing is the answer to how many, and the whole system clicks on at once. Every one of us learns counting from the outside in, the same way our ancestors first built it. So how did that machinery get built? It started with the tool you are looking at right now, the pair of hands in front of you. 10 fingers is not a random number to base a counting system on. It is the number you were carrying everywhere you went, always with you, impossible to lose. Across the world, again and again, people reached for their fingers first, which is why so many number systems are built on 10. Some are built on 20, from cultures that counted toes as well as fingers, often the ones who spent their lives barefoot. And the Sumerians, thousands of years later, ran part of their counting on 60, which is the strange reason your hour still has 60 minutes and your circle still has 360 degrees. You are using a Bronze Age habit every time you read a clock. Some peoples push the body far past the hands. In the highlands of Papua New Guinea, the Oksapmen traditionally counted along 27 points of the body, starting at the thumb of one hand, moving up the arm, across the nose and the eyes and the ears, and down the other side. To say a number, you named a body part. The number 12 was a place on your face. Their arithmetic lived in the shoulders and the collarbone. It is one of the clearest reminders that there is no single, natural way to count, only the ways different people invented. Fingers and bodies have one hard limit, though. They vanish the moment you look away. You cannot hand your neighbor your fingers and walk off. You cannot leave a number sitting on a shelf overnight. And the day a human first needed to hold on to a count that was too big for the mind and too important to trust to memory, something remarkable happened. A person picked up a bone and cut a mark into it. This is where the ground under the question gets very old. In a cave in the Lebombo Mountains, on the border of what is now Eswatini in South Africa, archaeologists found a small piece of baboon leg bone with 29 clear notches cut into it. It is around 44,000 years old. 29 notches. Roughly the number of days between one new moon and the next, and roughly the length of a menstrual cycle, which has led more than one researcher to wonder whether someone was tracking a moon, or a body, or simply a count of something that mattered enough to record. We cannot ask them, and that matters because it is easy to look at old marks and see whatever we want. Still, the object itself is not in doubt. Somebody sat down tens of thousands of years ago and turned a number into a row of cuts they could carry and show and check again later. That is the exact moment counting stopped being only a feeling and became a thing you could keep. The most famous of these is stranger still. On the shore of an ancient lake in the Democratic Republic of Congo, a man named Jean de Heinzelin uncovered a dark length of bone tipped with a sharp piece of quartz. The Ishango bone, around 20,000 years old, carries 3 columns of notches, grouped in a way that has kept people arguing for decades. One column holds groups that are all odd numbers. Another looks like doubling, 11, 21, 19, 9. Some see simple arithmetic. The researcher Alexander Marshak looked at bones like this and argued they were lunar calendars, a record of the sky kept notch by notch across the months. Here is where honesty earns its place. We do not know that the Ishango bone is a calculator, and we do not know that it is a calendar. It might be a tally of trade, or a pattern that pleased the hand that made it. What we can say is smaller and stronger. 20,000 years ago, a human being was cutting numbers into bone in deliberate groups, keeping a record that outlived them by 200 centuries. Whatever they were counting, they were counting. The pull to count the sky left marks in the ground as well. At a place called Warren Field in Scotland, archaeologists uncovered a row of pits dug about 10,000 years ago, 12 of them, shaped and spaced to follow the phases of the moon across the year, and to reset each midwinter against the rising sun. It is often called the oldest calendar yet found. Long before anyone wrote a date, someone here was keeping the year in a line of holes, counting the moons so the group would know when the salmon would run and when the cold was coming for them. And they had every reason to. Think about what a number was worth out there. You needed to know how many days of walking lay between you and the place the herds crossed the river. You needed to feel when the moon would be full enough to travel by. When a mammoth or a reindeer was brought down, the meat had to be split among the families, and a share that felt unfair could crack a group apart faster than any predator. A woman counting the moons of a pregnancy was doing math that decided whether a birth came in the warmth or in the killing cold. Out there, a wrong number had teeth. For a long time, the notch on a stick or a bone was enough. If you owed a neighbor a count of animals, you both cut matching marks into a piece of wood, then split it down the middle so each of you held half. Neither side could add a mark without the other's half failing to line up. That humble split stick was a contract, a receipt, and a lie detector all at once. And versions of it were still used to run national debts in Europe only a few centuries ago. On the far side of the planet, people found another way to hold a number without writing a single word. In the Andes, the peoples who rose into the Inca world kept their records on the quipu, a thick cord hung with dozens or hundreds of smaller strings, each one tied with knots at set heights. The position of a knot gave its value. Ones low on the string, tens above them, hundreds above that. A full counting system spun into thread. Trained keepers called quipucamayokes could read a bundle of knots the way you read a line of print, tracking storehouses and tributes and whole populations across an empire that never used an alphabet at all. Then trade grew heavier, and the notch met its limit. If you were moving 30 jars of oil and a flock of sheep and a load of grain, a row of identical cuts no longer tells you what you are counting, only how many. And around 10,000 years ago, in the Near East, people solved this with something so simple it is almost funny. They started using small clay tokens, a different shape for a different good, a little cone for a measure of grain, a sphere for a larger measure, a shaped token for a jar of oil, another for a head of livestock. The archaeologist Denise Schmont-Besserat spent years tracing these tokens across thousands of sites, and she saw what they became. To send a sealed count with a shipment, traders would push the tokens inside a hollow clay ball and seal it, so no one could add or remove a single one. But a sealed ball hides what is inside, so they began pressing each token into the soft outside of the ball before sealing it, leaving a mark. And then someone had the thought that changed the world. If the marks on the outside already say what is inside, you no longer need the tokens at all. You just need the marks. Those pressed marks, in the city of Uruk a little over 5,000 years ago, grew into the wedge-shaped script we call cuneiform, which means the first writing your species produced was not poetry and not prayer. It was accounting. People learned to write numbers before they learned to write their own names. The earliest tablets from Uruk are receipts. So many measures of barley, so many jars, so many workers, so many days. Civilization opened its first book, and the first book was a ledger. Even then, counting was far from finished. For thousands of years there was no zero, because why would you write down a nothing that you had none of? The Babylonians eventually left a gap, then a placeholder mark, to show an empty column. But zero as a real number, a thing you could add and subtract and treat as a value in its own right, arrived much later, worked out in India, and written down clearly by the mathematician Brahmagupta in the year 628. The number you lean on most when you balance anything was one of the last to be invented. You can feel how awkward the early systems were in the numbers the Romans left behind. Try multiplying 38 by 24 in Roman numerals sometime, and you will see why an empire that could throw roads across a whole continent still did its real sums on a board with little stones. Our word calculate comes straight from calculus, their name for one of those pebbles. For most of recorded history, doing serious math meant sliding rocks around a tray. Step back and look at the whole climb. You start with a rough animal feel for more and less, the same one a crow has. You bolt your fingers onto it, then your whole body, then a notch in a bone that lets a number outlive your memory. You wrap the bone count in clay tokens, then flatten the tokens into marks, then grow the marks into writing. Then, thousands of years on, you finally invent the nothing that makes the whole system snap into place. Every stage was somebody's breakthrough, made by a person who would never know your name. We love to say fire made us, or tools made us, or language made us. The humble notch belongs on that list, and almost nobody puts it there. The cut in the Lebombo bone let a human hold a number that no brain of the time could carry alone. That single trick, keeping a count outside the head, is quietly underneath every calendar, every harvest, every city that ever needed to feed more people than one family could count on sight. Now bring it back to your own hand. Every time you check the change in your palm, split a bill, read a clock, or count heads before the group leaves, you are using a technology tens of thousands of years old, one you were simply handed. You did not invent the idea that 5 is always 5. You inherited it from people who cut it into bone in the dark because they could not afford to forget. So, could ancient humans count? At the very start, only as far as you can without thinking, to a handful, and then a word that meant many. Everything above that they built, notch by notch and token by token, across tens of thousands of years, until the counting became so ordinary that their descendants forgot it was ever hard. You glance down at your hand and lift 4 fingers, and you know it is 4. Somewhere, long ago, a person cut 4 marks